Hello, my dear children. Welcome to my channel, Sudhir Sir Chemistry. Today in chemistry, for 11th class chemistry, we are going to learn about the foundation course. In the sense, beta, what are the things are requirement for the foundation course, and to know understand the 11th class chemistry completely. What are the important concept we should know? So that part I am going to discuss in our today's class. So in this, to understand better in the first year chemistry or in the 11th class chemistry, we are having three parts. One is a physical chemistry, another one is a organic chemistry, and third one is a inorganic chemistry. But organic and inorganic chemistry means to understand the organic and inorganic, we should know about the periodic tables. And to understand the physical chemistry, beta, we should know the laws given for that one. If you know that one, we are able to do physical part. So now today in the first class, I am going to discuss with you how many elements are there in the periodic table and what are the positions of these elements in the periodic table. Somebody will ask you what is the position of the nitrogen in the periodic table. What we can say, nitrogen is placed on a 15th vertical column of the periodic table, and that to be on a which period. So it is on which period means it comes on the, yes, second period, because lithium, beryllium, boron, carbon, oxygen and nitrogen. So it is a simple way I give, nitrogen is placed on which place or which positions of the periodic table. So in that way we should know all 118 elements in the periodic table and what are their positions in the periodic table, that also we should know. So I'm going to start with the periodic table of the first class, right? Listen here. But in this one, I'm going to discuss in this way. See here, the first element I'm going to write here as a hydrogen. This is the first element. It is a first element of first A group. Then under that hydrogen we are having here as a lithium. Then we are having as a sodium. Hydrogen, lithium, sodium, potassium, then rubidium, cesium, francium. See, but these are the elements are there placed on the 1A group of the periodic table. Hydrogen, lithium, sodium, potassium, rubidium, cesium and francium. If you want to remember this name in the order, we can say a simple word is that Hey Lina Kare Rab Se Faryad. It is a Hindi word. Maybe you can't remember, but remember. Hey means edge. Lina is a girl. Lina. Kare K. Kare means K. Rab God. Rab Se Faryad. Hey Lina Kare Rab Se Faryad. Hydrogen, lithium, sodium, potassium, rubidium, cesium and francium. Next sheet. After this one, we are going to start with the element as a Be, beryllium, then magnesium, calcium, strontium, then barium, and it will come here as a radium. See, remember Be stand for beryllium, Mg stand for magnesium, calcium, strontium, barium, and radium. Right? Next one is the third. Instead of writing the third group, I'll write all the D block elements. But here K means potassium, Ca means calcium. That is Ca means Ka, then Sak, T, V, Kar, Man, Fe, Ko, Ni, Ku, Zan. See what I said here. Kasak TV Karman Frekoni Kuzan. Ka means calcium. Sak TV. Remember in this way. Kasak TV. It is the one part. Kasak TV. Then Karman. Then Fekoni. Then Kuzan. Remember here. Kasak TV Karman Fekoni Kuzan. Once you see beta. Ka. Calcium. Sak. Scandium. Titanium. Vanadium. Chromium, manganese, iron, right? Cobalt, nickel, copper, and zinc. So it is a Kasak TV carbon feconi Kuzan. But we know that copper is an element we are using for what? To make the, yes, coins. So this group will be called as a coinage metal. We can make the coin of the copper, but we can make the coin of the silver, even we can make the coin of the gold. AG stand for silver, AU stand for gold. So copper, silver, gold, right? Then This is a way to remember, right, beta? What is that? Ca, ka, sak, TV. It is a one group. Ka, sak, TV. Then Karman, Fekoni, then Kuzan. In the group, you have to remember. Then these are the copper, silver, and gold. These are the coinage metal, right? Copper, silver, and then Au as a gold. But a zinc is there, Cd, cadmium, Hg is a mercury. Zinc, cadmium, mercury. Next to this, zinc, cadmium, mercury. Come for here, beta now. Scandium is there. Under the scandium, Y, yttrium. Under that yttrium, La, lanthanum. Under that Ac, actinium. Scandium, yttrium, lanthanum, actinium. Beta T, titanium. Then Zr. Then HF. Beta, how to remember this group? If you want to remember this group, I'll give the simple way to remember. But this word will come from the Hindi word. T, Zara, half. You know, better. I know children never drink tea, but those who are drinking the tea, how they will drink the tea, better? Tea zara half. Slowly, slowly they will drink. So tea zara half. TiZrHF. Ti stand for titanium. Zr stand for zirconium, and HF stand for hafnium. Right? T zara half. But the next one is we are having V, then NB, then TA. V NBTA. In Hindi, what they will say, वो नवाब था. वो ante V, NB ante Nawab, T ante tha. It's a Hindi word to remember, but these are the name of the element: vanadium, NB, and TA. But a chromium, under the chromium we should have molybdenum, and under that we are having one more W called as a tungsten. I know, beta, most of the children know about the tungsten because tungsten is a element or it is a filament present in the bulb. But when we are using the bulb, that is electric bulb, in that one we are having the filament, and that filament made up of what? W, tungsten. So chromium, molybdenum, tungsten. But Mn, Man, Tc, Man Takre. It is a way to remember. Mn, Tc, Re, Man Takre. Then but remaining here, leave it. Come for Ni. But Ni, after that we are having Pd, and after that we are having Pt. Sometimes children are getting confusion over it here. Sir, either it is having PT here or PD here. So better way to remember, beta. In both the cases, we are having P and P. But D and T means we know alphabetical order में D should come first and T should come later on. So PD as a palladium, PT as a platinum. See, beta, these are the element which one we make here now. I think you are able to see. Here, total number of vertical column in the periodic table we are having how many, beta? 18. And I will show you the all 18 elements in the periodic. 18 vertical column I will show you here. Right? Till here it is over. Till here it is, this one is over. Now, beta. So this part I think you understood. What is this part, beta? Hydrogen, lithium, sodium, potassium, rubidium, cesium, francium, beryllium, magnesium, calcium, strontium, barium, radium. Right? This is the part over. So, beta, what we can say, these are the part which one I am writing here. See, it is a dark line which one I kept here. From here to this part as a dark line which one we kept here, beta. These are the group of the element comes under the D block. These are the S, these are the D. That you are able to understand afterward, not now. Then come for after this one. Beta, zinc is here. Obviously, I should have Ga, gallium here. I should have Ga as a gallium. But before the gallium, what we have? We are having, one second, this one, right? I think you are able to see now, right? Good, good. So now, chalo now see here. But after that, we are coming here as a boron, then it will come here as a aluminium, gallium, iron is a indium, and Tl is a thallium. So we are having boron, aluminium, gallium, indium, and thallium. But the next one is carbon. But how to remember these? Is we are having any order to remember this one? Ki boron, aluminium, gallium, indium, thallium. Yes, but we are having one order. B stand for baigan, brinjal. Al stand for aloo, potato. That is a gallium stand for gajar. In, iron in, TL, thela, bag. So in Hindi, what they will say, beta? Baigan, aloo, gajar in thela. Baigan, aloo, gajar in thela. After that, we are having here as a carbon, then silicon, then germanium, Sn as a tin, and Pb as a lead. You can see beta carbon, silicon, germanium, tin, and lead. How to remember, chemistry sir, myself, gives simple problem. It is a way to remember, beta. Chemistry sir gives simple problem. Carbon, silicon, germanium, tin, and lead. Then come for here N, nitrogen, P, phosphorus, As, arsenic, Sb, antimony, and Bi is the bismuth. Once again I repeat, beta. Nitrogen, phosphorus, arsenic, antimony, bismuth. Then beta, oxygen, sulfur, then selenium, then tellurium, and PO as a polonium. Right beta? Acha, how to remember beta? N, P, As, Sb, and Bi, N means Nana Patekar, one of the hero is there. I think you didn't remember Bollywood. So Nana Patekar, Aishwarya, Sab Bekar. It is a way to remember. So nitrogen, phosphorus, arsenic, antimony, and bismuth. Then the oxygen, sulfur, selenium, tellurium, polonium. How to write this one? It is a old style say tail polish. But old style means it is in old style say tail polish. To way to remember. Otherwise, it is better. But you can do oxygen, sulfur, selenium, tellurium, and polonium. The next one coming as a fluorine, then chlorine, then bromine, I as a iodine, and At as a astatine. You can see bit of fluorine, chlorine, bromine, iodine, astatine. Next one we are coming here as a beta. This is a way to remember helium, neon, argon, krypton, xenon, and radon. So what we did beta here, N, P, As, Sb, Bi means nitrogen, phosphorus, arsenic, antimony, bismuth. Or how to remember? Nana, Patekar, Aishwarya, Sab, Bekar. Here beta, old style say tail polish. Beta here, fluorine, chlorine, bromine, iodine, and astatine. Uh, Fluorine, chlorine, bromine, iodine, and astatine. Helium, neon, argon, krypton, xenon, and radon. So, beta, these are the way to remember the periodic table. So, once again, I will tell you the way how to remember the periodic table. See here, hey Leena, करे रब से फरियाद, बेटा मांगे कार स्कूटर, बाप राजी, डैड राजी, बैगन आलू गाजर इन थैला, केमिस्ट्री सर गिव्स सिंपल प्रॉब्लम, नाना पाटेकर ऐश्वर्या सब बेकार, ओल्ड स्टाइल से तेल पॉलिश. Right? It is the only way to remember. Otherwise, anyhow, all the elements, name of the element we have to remember. Now we are going to see beta in this one. Now we are going to see in this one how to remember the atomic numbers of these elements. But atomic numbers of these element means you remember this part. Ki X is called as a symbol of the element. But X is the what? It is a symbol of the element. And the symbol of the element X will have two terms. One is a Z which is kept at the lower subscript, and another one is a but it is called as a mass number that is kept on the upper subscript. So Z is called as a what? atomic number of this element, atomic number of the element, and this A is a mass number of that particular element. We can say beta it is a mass number of the element. X is the symbol of the element, Z is the atomic number which is kept on left side lower subscript, and A is a mass number which is kept on left side at the upper subscript. These are the mass number. Now we are going to see the atomic numbers of this element, and to know the atomic number we should remember the part called as a magic number. Beta, if we know the magic number, we are able to write the atomic number of any element. What is the magic number? 288, then 18, 18 and 32. I repeat beta, 288, 18, 18, 32. These are the magic numbers. Now for example I will tell you, but I know that atomic number of hydrogen is 1. See, I kept on the lower subscript left side. But what is the atomic number of all the elements? So to write the atomic number of all the elements, just you do only one thing. Just see, you have to write the atomic number for how many elements. You can count here. After this one, after this hydrogen, 1, 2, 3, 4, 5 and 6. But we have to write the atomic number for remaining 6 elements. I repeat, 1, 2, 3, 4, 5 and 6. So to write the atomic number of 6 elements, but a magic number what we have, we are having 288, 18, 18 and 32. We have to write the atomic number for 6 elements, means count the 6 number from the back side. 1, 2, 3, 4, 5 and 6. Do one thing beta, 1 plus 2. Can you tell me 1 plus 2 is what? 3 is the atomic number of lithium. Beta 3 plus 8, 11 is the atomic number of sodium. 11 plus 8, beta 19 is the atomic number of potassium. What is that beta? 19 is the atomic number of potassium. 19 plus 18, 37 is the atomic number of Rb, rubidium. 37 plus 1 more 18, yes, it become a 55 is the atomic number of cesium, because potassium, rubidium and cesium. And now 55 plus 32, it become beta 87 is the atomic number of Fr, that is francium. See beta, it is a way to write the atomic number. Instead of beheading the atomic number, if you know the trick how to write the atomic number, this is the only trick that you have to remember. What is that? We should know the magic number, and we should know the atomic number of first element, and for how many elements we have to write the atomic number, that many numbers you have to come from back side. 1, 2, 3, 4, 5, 6. Then 1 plus 2, 3. 3 plus 8, 11. 11 plus 1 more 8, 19. 19 plus 18, 37. 37 plus 18, 55. 55 plus 32, 87 is the atomic number of francium. Next one beta, among this one, I know atomic number of nitrogen is 7. Now beta, I am asking you, can you write the atomic number of the remaining element which is kept under the nitrogen? So do only one thing. First see or check how many elements are there under the nitrogen for whom we have to write the atomic numbers. But under the nitrogen, how many elements are there? 1, 2, 3 and 4. So write our magic number once again. What is the magic number beta? 288, 18, 18 and 32. We have to write the atomic number for how many elements? 1, 2, 3 and 4. Count from back side. 1, 2, 3 and 4. Do beta. 7 plus 8. Yes, it becomes 15. And we know atomic number of phosphorus is 15. Beta 15 plus 18. Yes, 15 plus 18. 33 atomic number of arsenic. Right beta? Then 33 plus 1 more 8. 18. 51 is the atomic number of Sb. Sb symbol stands for antimony. 51 plus 32, it become a 83 is the atomic number of bismuth. Right beta? Again, anything in the group you find out and try to write the atomic number. Chalo, I will try one more. Sir, I know atomic number of fluorine is 9. What is the atomic number of the element which is kept under it? I will show you beta. First, write down what magic number. But what is the magic number we are going to write? 288, then 18, 18, and 32. But the atomic number of fluorine is 9, we know that. And we have to write the atomic number for how many elements under the fluorine? 1, 2, 3, and 4. So go from back side. 1, 2, 3, 4. Yes, 9 plus 8. Yes, beta. It become a 9 plus 8, 17. And we know 17 is the atomic number of chlorine. 17 plus 18, it become a 35 atomic number of bromine. 35 plus 18, yes, 53 is the atomic number of iodine, and 53 plus 32 become a 85 is the atomic number of astatine. Is it clear, beta? So just remember one more part. These are the element which is kept here, beta. Helium, neon, argon, krypton, xenon, radon. They all are the inert gas element. They all are what? They are the inert gas element. But they are also called as a noble gas element. They are also called as a aerogens. Aerogens means exist in the nature in the form of a gas called as a aerogens. Now, atomic number of helium, this all you have to remember, beta. Atomic number 2, neon 10, argon 18, 2, 10, 18, then 36, then 54, and then 86. You can see beta 9, 10, 17, 18, 35, 36, 53, 54, 86, 85, 86. So in this way, we are able to write atomic number of any elements in the periodic table if we know the atomic number of the first element of that group. So overall in this periodic table, beta, how many vertical columns are there? Already I told you, in this periodic table we are having 18 vertical columns. See beta, vertical column 1, then 2, 3, 4, 5, 6, then 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, and 18 vertical columns are there. But in these 18 vertical column, these all the element which is arranged in a vertically are called as a group. So we can say in this periodic table, how many groups are there? I should say 18 groups are there. Means element which is arranged in a vertically called as a group. So vertical column elements are called as a group. But how many periods are there? Period means it should be 7. That means the element which is arranged as a horizontally or horizontal arrangement of the element are called as a period. So this is a first period, this is a second period, third period, fourth period, fifth period, sixth period, and seventh period. Is it clear, beta? So these are the 7 periods are there and 18 vertical columns are there. But this periodic table, in that one first vertical column will be denoted as a 1A group. Second vertical column denoted as a 2A group. Means in this one, the groups are subdivided as A and B. But at present, why A and B and all that part we are going to learn in periodic classification of element. But as it is a foundation course, I want to explain you 18 vertical column divided in A and B group, how it will be. So first vertical column 1A, second vertical column 2A, but a third vertical column is a 3B. This is not the A. Then fourth vertical column, this is the fourth B. Fifth vertical column, this is called as a 5B. Sixth vertical column, this is a 6B. Seventh vertical column, this is a 7B. And a vertical column 8, 9 and 10 together called as a 8B group element. Vertical column 11, beta, it is a 1B. Vertical column 12, that is a 2B. See beta, these all the element which is kept on this dark line is nothing but the B, group B elements. How? 3B, 4B, 5B, 6B, 7B. Vertical column 8, 9, 10 together called as a 8B. Then beta 1B and then 2B. Vertical column 13, now it is called as a 3A. Vertical column 14, this is a 4A. Vertical column 15, this is a 5A. Vertical column 16, this is a 6th A. Vertical column 17, this is a 7th A. Vertical column 18 is called as a zero group element, called as a noble gas, inert gas, or aerogens. But one more point I will discuss with you. This 1A group element, which one you wrote here, na beta? 1A group element is called as a alkali metals. Remember, if I will ask you what are the alkali metals, what you have to say? All the 1A group elements are the alkali metals. But then 2A group elements are called as a what? 2A group element is called as a alkaline earth metals. If I will ask you, beta, what are the alkaline earth metals are there? You should say beryllium, magnesium, calcium, strontium, barium, and radium. I told you how to remember. Beta, mange, car, scooter, bap, raji. That is the alkaline earth metal. Very good. Then vertical column 3A, boron family. Vertical column 4 is a carbon family. Right? Then come for the vertical column number beta from the 5A. Now vertical column 5A is called as a nicogens. P will be silent. Beta vertical column 6th A, that means oxygen family beta. Now it will be called as a chalcogens. It will be called as a what? Chalcogens. Vertical column 7th A are called as a halogens. Are called as a halogens. And vertical column 18th group, that is a zero group, and it will be called as a what, erosions. So remember, these are the name of the elements. 1A group element called as a alkali metal, 2A group element called as a alkaline earth metal, then 3A boron family, 4th A carbon family, 5th A we can say nitrogen family, but it is also called as a what? Nicogens. 6th beta first element is oxygen. It is called as a oxygen family, but it is also called as a chalcogens. 7th A we cannot say it is a fluorine family. We should not say beta. 7th A group element also called as a halogens. Don't say the fluorine family. And 0 group 18 vertical column, these are called as a what? Erosions. So what we did in the class beta today, elements present in the periodic table, what are the positions of the element in the periodic table, how to write their atomic numbers. For writing the atomic number, we have seen the magic numbers and all. And vertical column 18, how it will be denoted as a 1A, 2A, then 3B, 3B to 7B, 8, 9, 10 together called as a 8B, 1B, 2B, and then 3A, 4A up to 7A and 0 group element. Right? Once you see this one, beta, any doubt is there, you can ask me. But now in this one, see, I forgot to write this one. These 4 columns are there. Iron, cobalt, nickel, copper, and zinc. But here Ru, RH, OS, and IR. Ru, ruthenium, RH, rhodium, OS, osmium, IR, iridium. So these are the elements present in the periodic table. Now, what we learn beta, I want to ask you what is the positions of the element in the periodic table. For example, I am asking you what is the position of the nitrogen in the periodic table beta. So what you should say, sir, nitrogen present on 15th vertical column, that means 5th A, and it is present in second period. See beta, remember, nitrogen present on 15th vertical column, and that is 5th A group, and it is present on second period. But to write this nitrogen position in the periodic table, we are having one small trick. I will show you that trick. Listen here. What is that? But it is a nitrogen whose atomic number is 7, and we have to write the configuration as a 1s2, 2s2, and 2p3. See, but your last electron enter into p orbital means element belong to p block, right? As the element belongs to p block, and whenever you want to write the group number for the p block element, what you have to do, we have to write the 12 plus number of electrons present in p block, or number of electrons present in p orbitals. So now what I should write, 12 plus how many electrons in the p orbital beta? 3. So 12 plus 3, it become a 15th vertical column. And as we know beta, 15th vertical column is nothing but it is called as a what? 5A group of the periodic table. And now if you want to write the period number of these one, and period number should be written as a number of valence shell. See beta, it is a 1 means first shell, 2s 2p means 2 is a second shell. That means it belongs to second period of the periodic table. You can check beta, Nitrogen is on the second period of the periodic table. So now question is that, sir, how to write these kind of the configurations and how to identify the group number for S block, P block, D block and F block. So that part we are going to learn after this one. So in this class what I have discussed with you beta, I have discussed the elements positions in the periodic table and what are the elements and how the elements should be remembered. That way I told you. Once again I am going to repeat beta. हे लीना करे रब से फरियाद, बेटा मांगे कार स्कूटर बाप राजी, बैगन आलू गाजर इन थैला, केमिस्ट्री सर गिव सिंपल प्रॉब्लम, नाना पाटेकर ऐश्वर्या सब बेकार, ओल्ड स्टाइल से तेल पॉलिश, राइट बेटा. And here fluorine, chlorine, bromine, iodine, acetine, what we can say, uh, I remember beta one of the mnemonic for this one, but at present I forgot. Only I remember this one. BR stand for biryani, which one I like very much. Biryani in Attapur. So FCL, what we can add beta? FCL. Uh, I can't remember the way, but FCL something is there. BR stand for biryani. I stand for in. AT stand for Attapur. Biryani in Attapur. What the FCL indicate, I don't know. Sorry for that. Then remember helium, neon, argon, krypton, xenon, and radon. Right, beta? So this is the way we have learned today in the periodic table. Now the after that one I am going to start for you how to write this kind of configuration and how to find the positions of elements in the periodic table. Please take a screenshot of this one. ये ना, ये ना, नीचे का. But now after this periodic classification, I will teach you, I told you how to write the electronic configurations. But for writing these electronic configurations of any elements in the periodic table, see here, these are the electronic configurations of the elements in the periodic table. But electronic configuration means nothing but a distribution of electrons in the orbital. Means for that one we should know what is the structure of the atom. But as we know, the structure of atom is a spherical having positively charged center, and this positively charged center is called as a nucleus. And now around this nucleus beta we are having a orbits, and in each orbits we are having some electrons present over it. Let me tell you beta, this is denoted as a K shell, then this is a L shell, then this is a M shell, and this is a N shell. K, L, M, N shells. It is numbered as a, see beta, this is also numbered as a N equal to 1, N equal to 2, N equal to 3 and N equal to 4. So this numbering N1, N1, 2, 3, 4, these are called as a orbit. These are called as a beta orbit. Second orbit, third orbit. 2 is called as a second orbit and N equal to 1 is called as a first orbit. So beta, when it is numbered as a 1, 2, 3, 4, we can call it as a orbit, and when it is denoted as a K, L, M, N, called as a shells. So shells and orbit. But I mean in previous class, lower classes, what we learned, कि this N equal to 1 it is having only 2 electrons, N equal to 2 is having 8 electrons, N equal to 3 is having 18 electrons, and N equal to 4 this is having a 32 electrons are there. But now we will see why the first orbit is containing only 2 electrons, second orbit is containing 8 electrons, third orbit 18 and fourth orbit is a 32. Why? Because we know beta, first orbit is containing only one orbital. What is that only one orbital beta? 1s. So what is this 1s called as a? This is called as a orbital. So orbital is present in the orbit, but a 1s means only one box called as a one degenerate orbital. N equal to 2 means it is having two orbital. One is a 2s, another one is a 2p. But wherever you will see s, it is having only one box. This box is called as a degenerate orbital. But wherever you will see p, p is having three degenerate orbitals. That means it is having a three boxes. See, one is having 1s, 2 is having 2s and 2p, 3 is having what beta? 3s, 3p, 3d. 3s means one box, p means three boxes, and d means how many? Five boxes. Remember the 1, 2, 3, 4, 5. N equal to 4. It is having how many orbital? 4s, 4p, 4d, 4f. S means one box, P means three box. But this is not the boxes. These are called as a degenerate orbitals. Means orbitals having equal energy that we are going to learn afterward. D is having five boxes and F is having how many? Seven boxes. 1, 2, 3, 4, 5, 6, 7 boxes. Right? Now, but as it is having a 1s orbital, mean one box contain only two electrons. So I can say n equal to 1 is having only two electrons. But what about n equal to 2? This one box containing two electrons. These three boxes having how many? 1, then 2, then 3. Then start pairing according to 1's rule 4, 5, and 6. 6 plus 2, 8 electrons on the second orbit. Now third is having how many? 18. Count it here. 1, 2. 1, 2, 3, 4, 5, 6. 6 plus 2, 8. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 plus 6, 16 plus 2, 18. And here, better to count number of boxes into 2. Here how many boxes? 7. Here how many boxes? 5. 7 plus 5, 12. Plus 3, 15. Plus 1, 16. 16 twos are 32 electron in the fourth orbit. So these are the distributions of electrons in each orbit, and it is based on what? Because first orbit is containing only one orbital. What is that? 1s. Second orbit containing two orbital. Which one? 2s and 2p. Then 3s, 3p, 3d, 4s, 4p, 4d, and 4f. So these are called as a distribution of electron in a particular, or we can say in a given orbits. See beta, first orbit containing only 2 electrons, second orbit containing 8 electron, third orbit containing 18 electron, and fourth orbit containing how many? 32 electrons. So these are the distributions of electrons in each orbit, and based on that we can say first orbit containing only one orbital. What is that? 1s. Then 2s, 2p, 3s, 3p, 3d, 4s, 4p, 4d, and 4f. Right? This is the one part about that one. But now I am going to teach you distributions of the electrons in each orbit, or in each, or what you can say in each orbit. It can be given by the diagram called as a Muller's diagram. Because in our lower classes, what we have to write beta, sodium whose atomic number is 11, we used to write its electronic configuration as a 2, 8, 1. But now in the higher classes, instead of writing these way beta, we have to write the configuration as a 1s2, 2s2, 2p6, and then we have to write here as a 3s1. So how we are able to write these distribution of electrons in the given orbital? I told you beta, 1s is a orbital, 2s is a orbital, 2p is a orbital, 3s is a orbital, and distribution of electron in each orbital, it can be given by the diagram given by Muller's. That is based on the Muller's diagram we are able to write this kind of the configuration. So that one we are going to write now. Please take a screenshot of this one. Now beta, we are going to write, that is electronic configuration based on the diagram given by Muller's, and this is called as a what? Muller's diagram. But based on that, means Muller's, he help us to write the configuration. Means based on this Muller's diagram, we are able to write the first electron will enter into which orbital, and after filling that orbital, it will enter into which orbital. Means increasing energy orbitals will be there. How to write the Muller's diagram? This is also we are having one trick here. See beta, what is the trick we are having? 1, 2, 3, 4, 5, 6, 7, 8. Means 1 to 8. Then leave one line here. Give one dash here. 2, 3, 4, 5, 6, then 7. Then give 2 dash here. Then give 2 dash here. Then 3, 4, 5, 6. Right? Then give 3 dash here. Give 3 dash here. then 4 and 5. See beta, these all are the s orbitals. And as we know beta, s orbital is having only one box. That means 2 electron. All these are having p orbitals. Beta, p orbitals is having 3 boxes. These are the d orbitals. And these are the f orbitals. See, I'm writing here 1s, 2s, 3s, 4s, 5s, 6s, 7s, and 8s. Right? These all are the orbitals. I repeat again, beta. These all are the orbitals. Now, beta, electron, how it will enter? See, beta, we have to give one arrow. One arrow, one ball. See, one more arrow, one more ball. Means one ball. Ball means orbital. Then, beta, again two balls came here. Again two balls. See, beta, one ball, then two ball. Then, beta, three balls. Three, and here also three balls. Then four balls. 2, 3, and 4 balls. Here also 1, 2, 3, and again we are having beta 4 balls. That means what this arrow indicate beta? That arrow indicate that electron will enter into that particular orbital. Means first electron will enter into which orbital? 1s. After filling 1s beta, backward movement should be there. And now it will enter from here. Then it enter into which orbital? 2s. But after filling 2s, again the backward movement should be there. See? Backward, and now it will enter here. It goes to where beta now? 2p orbital. After filling 2p, it enter into 3s. And then after 3s, backward movement should be there. You can check it beta, backward movement I am writing here. This is the backward movement. And now it enter here. Where it goes? 3p. 3s, then 3p. But after filling 3p, where it goes? 4s. Chalo, after 4s, now you have to do yourself. It goes in this way, enter from here. It goes to beta now 3d. After 3d, where it goes? 4p. After 4p, where it goes? 5s. Place is not there. I am writing. Then after 5s, it enters into which orbital? Check it here. Sir, it enters into 4d. Then after 4d beta, 5p. Then after 5p, it goes to 6s. Then it goes on this way. So what we understood beta? Ki whenever s orbital is there, we should give only one box. Remember, for s orbital only one box. But whenever p orbital is there, it should have 3 boxes. This is the number of box. If d orbital is there, it is having 5 boxes. Actually, these are not the boxes, beta. It should be called as a degenerate orbitals. Means the orbitals are having equal energies. 5 boxes. And f orbital, it is having how many? 1, 2, 3, 4, 5, 6, and 7 boxes are there. So these are the degenerate orbitals, right? And each box can fill the 2 electrons. Now we'll try to write the configuration beta. Let us say sodium, whose atomic number is 11. Beta, atomic number 11 means that particular element is having 11 electrons. Now how it will enter? First it enter into 1s. So 1s. Beta, s can fill how many maximum electrons? 2. After 1s, it goes to where beta? 2s. 2s means s orbital can fill electrons how many? 2. So 2 plus 2, 4. After 2s, now we are going backward movement 2p. So we enter to 2p. Beta, p can fill maximum how many? 6. Now count here. 2 plus 2, 4. 4 plus 6, 10. And after 2p, it goes to 3s. And as we know beta, 3s can fill maximum of 2. But at present, how many electrons left with us? Only 1. How? Atomic number is 11. And we fill how many electrons? 2 plus 2, 4. 4 plus 6, 10. Right? 10 plus 1, 11. This is the configuration of sodium. Beta, see, this 1 indicates first orbit, that is a K shell. 2 and 2 indicates second orbit, that is a L shell. And 3 indicate that is a third orbit, M shell. That means K shell is having how many electrons, sir? 2. L is having 6 plus 2, 8. And M is having only 1 electron. This is a 1. But in lower classes, what we learn, atomic number of sodium is 11, but configuration should be written as a what? 2 comma 8 comma 1. But actually in higher classes what you have to write, instead of writing 2 comma 8 comma 1, we have to write here as a 1s2, 2s2, 2p6, 3s1. It is a configuration. But we can try one more. For example, I am going to write Zn as a zinc whose atomic number is 30. How to write the configuration of this one? See beta, 30 means start from here. 1s2, then 2s2, then 2p. You know p can fill maximum of how many? 6. 2p6. Then 3s2. But after 3s we enter from here to 3p. You know maximum of electrons in p orbital how many? 6. Then 4s2. But till here how many electrons here? Just you count. 2 plus 2 4, 4 plus 6 10, 10 plus 2 12, 12 plus 6 18, 18 plus 2 20. We are having how many? 30. After 4 years we enter into 3D, and you know beta, D can fill maximum of 10. 20 plus 10 30. One more point I will tell you. But in sodium, your last electron enter into which orbital? So it enter into s orbital. That means I should say, but my sodium it belongs to s block elements. But in zinc, your last electron enter into which orbital? So it enters into d orbital. That means I should say my zinc element it belongs to where beta? It belongs to d block element. So did you understand which element belongs to S block, which element belongs to P, and which element belongs to D and F block? But the last electron enter into which orbital? Element belongs to that one. One example I will show you. For example, see here now one example, chlorine beta. Atomic number is 17. Chalo, write the configuration 1s2, 2s2, 2p6. Count beta. 1s2, 2s2, 2p6, 3s2. How many electrons over beta? 2 plus 2 4, 4 plus 6 10, 10 plus 2 12. Then after 12 we enter here, and 12 plus 6 18, but we are having left with only 5 electrons. Because see, 2 plus 2 4, 4 plus 6 10, 10 plus 2 12, and 12 out of 17, 12 electron already we distributed. How many electrons are left now? Only 5. So I should write 3p5. So but these last electron enter into which orbital? Sir, it enters into p orbital. That means I should say my chlorine, but it belongs to p block elements. Means in that periodic table, all these elements they are classified based on the blocks. And what is that based on the block beta? It is somewhat like that. See here, these are the distribution of element. All the left side is a S block, all the right side is a P block, in between the D block, and at the bottom of the periodic table we are having F block. So did you understand beta how the elements are classified? It is classified based on the blocks, and based on the blocks how to find out that last electron enters into which orbital. And you know beta, this last electron is called as a what? This last electron is called as a, yes, that is called as a differentiating electrons. Differentiating electron means that electron will differentiate that element from the previous, called as a differentiating electron. Or you can say valence electron, better way beta. The last electron called as a valence. So differentiating electron, if it enters into s orbital, that element belongs to s block. If the differentiating electron enters into d orbital, that element belongs to d block. And if the differentiating electron enters into p orbital, that element comes under what? P block. And if the differentiating electron enters into f orbital, that elements comes under f block. So beta, what I will tell you, based on this Muller's diagram we are able to write this kind of configuration, right beta? So these kind of configuration you practice from the atomic number 1 till atomic number 55, 54, 55, not only 30 beta, till 54, 55 you try it. So it is a general way to write the configuration. Now I will teach you beta one more, that is called as a condensed form. For example, I will tell you sodium whose atomic number is 11, but it's a condensed electronic configuration should be written as what you know, neon 3s1. So how to write these configuration? What about these? But these configuration we are writing based on what Moore's diagram. But now again one more advanced level we'll go. Instead of writing this configuration, we are going to learn how these kind of the condensed configuration of any element or any element whose atomic number is given, how their condensed configuration can be written. That we are going to learn after this one. Right? Please take a screenshot of this one. But after writing these condensed configurations of the elements, now we'll see how to write the condensed electronic configurations of the element. So we are going to learn now condensed electronic configurations of the element. And to write the condensed electronic configuration, but what is the thing you have to remember? We have to remember the noble gases: helium, neon, argon, krypton, xenon, and radon. So remember the helium, neon, argon, krypton, xenon, radon. Helium, neon, argon, krypton, xenon, and radon. But of their atomic numbers you have to write 2, 10, 18, 36, 54, 86. If something element is here, after that their atomic number becomes 118. So I am going to teach you what better now? Condensed electronic configurations. For this one, what is the things we should remember? We have to remember these noble gases element: helium, neon, argon, krypton, xenon, and radon, and their atomic number 2, 10, 18, 36, 54, 86, and 118. Chalo, we'll write the first one. So sodium, whose atomic number is 11, how to write its condensed electronic configuration? For writing this condensed electronic configuration of sodium, beta, just see its atomic number is what? 11. Number 11 comes in between which two? It is coming between 2 and 10? No. It is coming between 10 and 18? Yes. So beta, atomic number 11 comes in between 10 and 18. I should call beta lower number is a 10, and symbol is what? Symbol of this one is any neon. So I should write here as a square bracket, then neon, atomic number 10 we have to mention. And after that we are coming now here, it is argon, but argon belongs to which period? Third period, which start from 3 years. 10 plus 1, 11. So again I will repeat, beta. Helium, it is the last element of the first period. Neon, it is the last element of what? Second period. Then argon, third. Krypton, fourth. Xenon, fifth. Radon, sixth. So these are the elements present on that particular periods. But the first period start from 1s, second period start from 2s, third period start from 3s, fourth from 4s, fifth from 5s, sixth from 6s. Now you can see what again I tell you. Atomic number 11 comes in between which two number? It is coming in between 10 and 18. But which is a lower number? 10. Symbol is any. Write the symbol in square bracket and put the atomic number as a 10. Now we are coming from under that one, because after 10 we are coming at the below of that one. Means we are coming on which period? Third period. And do you know third period start from 3s? 3s. Electrons how many? 11. How many we utilize? 10. Left one is 1. Chalo, one more example. K is a potassium atomic number 19. But atomic number 19 comes in between which two? 10 and 18? No beta. 18 and 36. Lower number is 18. Symbol is AR. So I should write square bracket AR, argon, atomic number 18. After that we are coming here, which comes on fourth period, and fourth period start from where? 4s orbital. Very good. Beta 18 and now 19, because atomic number 19, 18 plus 1, 19. Chalo, third one we'll write. Beta zinc is the element whose atomic number is 30. Chalo, number 30 comes in between which two number? Beta number 30 comes in between 18 and 36. So which is a 18 and 36? Which is a lower number? 18. I should write here as a argon symbol for 18. And then we are coming under here, which comes on fourth period. And fourth period start from where, beta? 4s orbital. Now 18 plus 2, 20. Do you remember Muller's diagram? But in the Muller's diagram, after 4s we are entering on 3D. 3D is having 10. So 18 plus 2, 20. 20 plus 10, 30 is the condensed configuration of what? Zinc. One more we'll try with a fourth one. Chlorine, atomic number 17. Number 17 comes in between which two number? 10 and 18. But a lower number is 10. So square bracket, then any neon 10. After that we are coming on this element which comes under third period, and third period start from 3s. That means 10 plus 2. And according to Muller's diagram, after 3s, where we go, beta? We go to the 3p. 10 plus 2, 12. 12 plus 5, 17. This is a condensed configuration of what? Chlorine. I think you remember, beta, how to write the condensed electronic configuration of any element. So what we learn in today's class, first of all the elements in the periodic table. The easy and simplest way to remember the elements in the periodic table, if we know the atomic number of one element, we are able to write the atomic number of all the elements present in that vertical column by knowing the magic numbers. And afterward, how to write the electronic configuration based on the Muller's diagram. And next one, better, how to write the condensed electronic configurations of the element, right? After this we are going to learn that how to find the positions of the elements in the periodic table. First of all, for that one, what we should know, beta, element belongs to which block? Because these all the elements in the periodic table, they have classified based on the block: S block, P block, D block, and F block. Based on these blocks, it was classified, and based on these block, we are able to find the positions of the elements in the periodic table. That part we are going to learn in next class, right? Thank you, beta. Thank you very much.